In this video, I will demonstrate how to download and locally run the Flux-1 model by Black Forest Labs. Currently, there are two models that we can use for free, Flux.1-dev and Flux.1-schnell. While both models are free, if you have any commercial uses, you will need to use the Schnell model since it has an Apache 2.0 license. The dev model cannot be used commercially. In VS Code, I have a fresh project with a requirements file that contains all of the libraries we will need for this. I also have an env file which holds my Hugging Face API key, and I already created a virtual environment, which I installed all of these libraries for just to save time. So the first thing I will do is create a file for our model. Then back on Hugging Face, we'll click Use This Model, and we are using the diffusers library, which we installed in the requirements. So we will click Diffusers, and then hit Copy. Now we can paste that in our model. Now we also have to include a login for Hugging Face. Since I am using an environment variable, I just had to load that in real quick. And then I named my environment variable API key, so that is why I put that there. And then here we have it. Also, it tells you to do the diffusion pipeline. You actually want the Flux pipeline. Now, I am also going to save this model locally because I do not want to load it from Hugging Face each time. It takes quite a while if you do that. So saving it locally will speed it up immensely. I'll create a new directory for our saved models, and I'll create one for Schnell. And then to save it, we just have to route it to that directory. One last thing we must do is import torch, and we need to set a torch data type. And I believe a float16 will work for that. And then hopefully, assume everything is correct. If we run this file, it should save the model to our Schnell directory. Login successful, that is good news. Now that our model is done installing, we should find its local files in the directory that we specified. And now we could take this path and save it in a variable. And instead of loading it from Hugging Face, we will load it from that path. Now we can generate an image. So a few things to do before that is, if you are struggling with memory, then you could enable sequential CPU offload, which essentially just lets the CPU do some of the processing. And then we will use a prompt, which we have not created that variable yet for. Guidance scale, and that is essentially how closely the image generation follows the prompt. We will do PIL for pillow. The number of inference steps is, you could play around with that. The more steps you do, the higher quality the image will be, but it will also take longer to generate, so you'll just have to find what works best for your needs. Max sequence length. And then for the generator, we are going to use torch.generator. And then a seed for a bit of randomness. And then from there, we could access the images generated by doing .images, and it will be in a list. So we want to grab the first index. And then we could save that image. I'll just do images, and then we will give it a file name. So we have two variables to create: file name and prompt. Just as an example prompt, I'll do planets colliding into each other, view from the surface. And then we'll just do planet collision as our file name. And then we also have to create an images folder. And that should have us set up for creating an image, hopefully. And as we'll hopefully see here, the loading the model part will be a lot faster since we saved it locally, and we are loading it from the path. Logged in successfully again. And yeah, all that loaded much quicker. Torch not compiled with CUDA enabled. So this is actually good that we got an error like this, because we could resolve it in real time. I'm assuming that we need the PyTorch with, okay, here we go. I have CUDA 12.4. So choose the CUDA version that you have, and then we will copy this. And hit install. So now that Torch is installed with CUDA support, we will attempt to run the model again. And we could see our image is successfully generating right now. It is out of 15 inference steps. And again, this portion of it will take a while depending on your hardware, so do not worry if it takes quite a few minutes. Alright, now our image is done generating, and we can see it's in the folder Planet Collision. Well, it looks alright. I definitely could have prompted it better, but, you know, at least we have an image generating. That is good. I'm gonna kind of wrap this into a class to make it a bit more functional. So I'll just make a general Flux model class where then it could be inherited by a Schnell or dev model. Hopefully that'll make a bit more sense in a moment here. So class, Flux model. We'll do name. And then we could have a function to load the models. And we'll make a function to save the model as well, which we could actually take the load function again, but we will need the original name of the Schnell model. Which I guess actually would just be our self.name variable, but let's put that up here for now. And then save path. Now we can make a get result function. It will take a prompt, it will take a file name, and then we could do pipeline equals self.load model, and we will get a pipeline variable returned from that function. Enable the sequential CPU offload again. And then we could just take our function from down here, or not function, but block of code. And we have that set up correctly, I think. Now I will make a Schnell file specifically. The Schnell class will inherit the Flux model. And then we will do name equals this text right there. The save path is saved models Schnell. At least it is for my project. It may be different for yours. And then I'm going to add another name to just say Schnell right there. then we'll pass the name, the save path, and then I'll add a model variable to just for testing purposes, I will create a init file from and just to test if we set everything up correctly, I will try, I don't like get result, get image. Get image, we'll say create a hyper realistic image of a T-Rex. And then our file name will just be T-Rex. And let's try to run it. And now that the image is done downloading, we should see it in the images folder. And it turned out alright. I wouldn't say it is exactly the most realistic T-Rex I've ever seen, but raising the inference steps would probably help with that. I just didn't want to make it extremely long for the video. But also just to show how easy it is now that our models are in kind of a class structure. You can make a dev for the Flux-1-dev. Copy that. Make a dev folder for our saved models. And then now we will do dev.saveModel. So as you can see, it will take a while again because we haven't actually done anything with the dev model yet. Previously, all the downloads were for the Schnell model only. Now that our dev model is done downloading, we should hopefully see the files in the Save Models folder, which we do, so that's good. So now we can load the dev model just as we loaded the Schnell model before, and likewise we could also get a result from the dev model just as we did with the Schnell model. The code for all of this will be in the GitHub link below.